Hello students, welcome to the concept CE short circuit current gain, which is an important topic in the concept of high frequency analysis of amplifier circuits. What is this concept CE short circuit current gain? Because this is the concept of finding current gain. Yes, you are going to find the current gain. Why we are finding short circuit current gain? Short circuit current gain means this is the current gain of the amplifier circuit when the output gets shorted. What is here the short circuit? Here, see the circuit. This is a circuit for hybrid pipe, CE amplifier with load RL. Okay, this is the load RL. So this is the general circuit. See, for any amplifier, the output is across a load resistor RL, which is an external load resistor. Okay, this is the general circuit. But here we are finding CE short circuit current gain. The reason why we are going for this topic, see, when this is short circuited means you are removing the external element. Means at that time you are evaluating the performance of only the transistor circuit. Okay, only the transistor. See, except this RL, this entire circuit is the circuit of or the internal circuit of the transistor. So now when you short circuit the CE amplifier, means by removing RL, by making RL is equal to 0, means you are evaluating purely the performance of your transistor. Purely the performance means purely the current gain of the transistor. You know the current gain is output current by input current. Okay, so let us start this. In the next video, I will do CE current gain with resistive load. By keeping the resistive load, I am going to find again the current gain. There the concept is how the total amplifier circuit will produce gain. How the gain is changing with respect to the load. What about the gain when the resistive load is present? Means there I am going to evaluate the complete performance of the amplifier. Because when you connect the RL, it becomes the amplifier circuit because you are connecting external resistor to the circuit. But when you are eliminating the RL, means you have only the transistor internal circuit in the circuit. That is the reason here we are going to find or we are going to evaluate a gain of the transistorized circuit. Okay. So now let us find. So now let us draw when RL is shorted. This is the circuit when RL is shorted. See here, this RL is shorted. Okay. So now this current which is flowing from the collector into the circuit is IC, and the current through short circuit, consider it as IL. RL is 0, but maximum IL is there. As you shorted the RL, V out, which is IL/RL, is equal to 0. Voltage is 0, resistor is 0, but current is maximum. You know it very well. So now we'll find what is the current gain for this circuit. Okay. So now see, yes, this is shorted means, yes, this is shorted, RL is shorted. If you see RCE is in parallel with the short circuit. So RCE gets shorted. So this RCE gets shorted. And when it gets shorted, see this gets connected to RCE which is shorted. Short means this is ground here. This end is also at 0, means ground. Okay. Means RB dash C and CC both are connected to the ground. Okay. I'll draw the circuit. This is grounded and this is also grounded. What is this? This is CC or CB dash C. This is RB dash C. Both are grounded. The current source GM VB dash G remains same. Okay. So this is IL and this is collector current, and this is collector current IC. Okay. So this is a circuit. In this circuit, RB dash C and RB dash E both are in parallel. RB dash C is low and RB dash C is very high. So a low resistor in parallel with a high resistance gives low resistance, you know. Yes, the parallel combination of RB dash E and RB dash C. Yes, what is this? RB dash C in parallel with RB dash E is approximately equal to RB dash E. Okay. Another point here, CE and CC, CB dash E and CB dash C both are in parallel. Capacitor, if the two capacitors are in parallel, the result capacitance is the sum of these two capacitances. So I'll draw the entire circuit again. Only one capacitor I am keeping, that is CE plus CC. Here you have this current source GM VB dash E. So this is the final circuit. Now we'll find the short circuit current gain. Current gain AI. Output current. What is the output current? IL. What is the input current? Consider it as IN. Let it be IN. Okay. So IL. IL is nothing but minus IC. See here, IL and IC both are in opposite direction. And IC is in the direction of GM VB dash E. You can consider this as minus GM VB dash E. And what is IN? IN is voltage. See, you have, I'm using the concept V is equal to IR, we know. But I want I, that is V by R. Instead of taking the denominator resistance, I am taking VG. That is the reason the concept is hybrid pi equivalent circuit concept is in the form of conductances where G is conductance. Okay. So now, see, this is the input current. What is the voltage here? VB dash E of, what is the conductance? You have to take the resultant, the total conductance of RB dash E and this branch CE plus CC. So what is the conductance as the two are in parallel? Actually resistance parallel means you have to go for R1 R2 by R1 plus R2. But we are taking the conductance. Conductance means you can sum. Just sum though it is parallel combination. That is the advantage of taking conductances. So the first conductance RB dash E. Yes, you can write it as GB dash E. As we are taking the conductances, though it is parallel combination, you can take plus, means you can add. Then the conductance of CE plus CC, you know the reactance. Reactance is 1 by j omega c. Okay, then the conductance here is G is 1 by X, that is j omega c. So with this I am taking here j omega of Ce plus Cc. Okay, so now what is Ai? Therefore, current gain Ai is minus Gm Vb dash E by Vb dash E of Gb dash E plus j omega of Ce plus Cc. Cancel this, and this is minus Gm by Gb dash E plus j omega of Ce plus Cc. We know Rb dash E is equal to HFE by Gm. Implies Gm is HFE by Rb dash E. That is HFE into Gb dash E. 1 by Rb dash E is Gb dash E. Implies Ai is minus HFE into Gb dash E by Gb dash E plus j omega of Ce plus Cc. So cancel Gb dash E in the numerator and denominator. We'll get Ai is equal to minus HFE by Gb dash E gets cancelled, 1 plus j omega of Ce plus Cc by Gb dash E. Write this omega as 2 pi f into Ce plus Cc divided by Gb dash E. Let the parameter f beta as Gb dash E by 2 pi of Ce plus Cc. It implies your Ai as minus HFE by 1 plus j f by f beta. If you take modulus, mod Ai is HFE by, if you take modulus, as this is the complex, it will just go like this, 1 plus f by f beta whole square. So this is the expression of Ce short circuit current gain. Okay. So I'll stop here. In the next video, I'll extend this concept. I'll explain what is f beta, and I'm going to explain ft. Okay. Means the limits of this current gain, where the current gain drops to 1 by root 2, where the current gain becomes 1. I'll explain the next video. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.